Okay, let me show you how to solve this problem. This is A-level sorts. We have to evaluate the integral of square root of 1 plus x squared dx, where the limit is from 0 to 1, right? So this means that we are finding the area under the curve square root of 1 plus x squared, right? Where x is 0 to 1. Okay, so solution. Now, this kind of integration has a standard integration formula that relates to it. So you are either given in the exam or you are expected to recall it. So let me bring the standard integration formula so that we can use it to solve this just by substitution. It's very easy. So just follow gradually. So the standard integration formula is given by integral of square root of a squared plus x squared dx should be equal to 1 over 2 x square root of a squared plus x squared. Then we'll have plus a squared ln open bracket x plus square root of a squared plus x squared, then plus c. So this is the standard integration formula that relates to this kind of a problem. So what we are expected to do now is to substitute. So if you relate this standard integration with this, you observe that a squared now represents 1, right? So if a squared is 1, so let's substitute it into this value now. So we have integral of 1 to 0. So we have square root of, instead of a now, we'll put 1. A square, we'll put 1. So anywhere we see a square, we'll just represent it with 1 there. So it will look like this. So we have 1 plus x squared dx becomes, so we have 1 over 2 open bracket x square root of, now a square is 1, so we have 1 plus x squared. Then we have plus a is still 1 here, 1 squared ln x plus square root of 1 plus, because 1 square is 1, right? X squared, then close bracket. Okay, so this is the substitution of the value. All right, so if this is complete, then what we have to do now is to look for the upper limit. Upper limit as x is 1, right? So anywhere we see x, we'll substitute 1 into it for the upper limit, so that we'll be having, it tends to now 1 over 2 into x is 1, recall 1, then square root of 1 plus 1 square is still 1, right? Okay, so plus 1 square is still 1, so we can just write ln, then x is still 1 plus square root of 1 plus 1 square is still 1, right? So we'll close the bracket. So to conclude this calculation, we'll be having 1 over 2. Now 1 multiplied by this is still that very value. So we'll be having square root of 1 plus 1, 2. Then we have plus ln, this is 1. So we have 1 plus, this is 1 plus 1. So we still have square root of what? 2. All right. So this is the conclusion for the upper limit. So let's go to the lower limit. Lower limit as x tends to what? 0. So we'll put 0 anywhere we see x. So we have 1/2, open bracket, this becomes 0, square root of 1 plus 0. 0 square is 0, right? Then plus ln 0 plus square root of 1 plus 0 again. So we close the bracket. To conclude this, we're going to be having 1/2 into, this is 0 times this will give you 0, right? So we have 0 plus, this is going to give you ln, open bracket, 0 plus, so since this is 0, 0 can just go away, right? Addition is commutative, so we just have this one. Square root of, this is 1 plus 0, square root of 1, right? Okay, so this is going to give us 1/2. This is 0, it will go. So we have ln, square root of 1 is 1, so we have ln 1, right? Now, we already know that ln 1 is 0, right? Ln 1 is 0. So 0 times half, your final answer will be 0 for the lower limit, right? So when we do, because of this limit, when we do upper limit, take away lower limit, we'll then be having this, which is the upper limit, square root of 2 plus ln 1 plus square root of 2, right? Minus 0. This, the lower limit is 0. So the answer will just be this. This is the final answer for the integration of this surd under this area where the limit is 0 to 1. Okay, so this is where we are going to stop. I'm going to see you in the next video. Please remember to share, remember to subscribe, and don't forget to turn on your notifications so that the moment I put on new videos, I upload them, you'll be the first to be notified. So thank you for being here. Try to comment, ask questions where you are confused, and I'll be there for you. Thank you and bye for now.